welcome to another episode of FooBar. Today we are going to talk about security in cloud native applications and more specifically in containers. If you want to know more about serverless, cloud computing and software engineer practices in general, subscribe to my channel in the red button below. I post videos on Tuesdays and on Thursdays, so let's get started! This is another episode in my series This is not a podcast, and today I have a very interesting episode. I have been talking about containers in a couple of past episodes where we go to the basics, and today I have an amazing guest. I'm going to talk with Liz Rice, that she's a security expert, AWS container hero, and she will help us to understand all the things that we need to have in mind when working with containers in the cloud and also with cloud native applications in general. So let's get to the interview. Hello and welcome to this episode. Today I have a very impressive guest. It was so hard to decide how to introduce her. She's an AWS container hero, the author of a book on container security and the security VP of Aqua Security, and so many other things. I will let her introduce herself. Welcome, Liz Rice. How are you doing?
I'm doing great. Thank you very much for having me.
I'm super excited to talk to you. You're like super prolific, a great role model for all the ladies out there and guys as well, but it's always super nice to chat with amazing guests like you too.
Oh, thank you. Yeah. No, this should be fun, right?
Yeah, I'm very excited to talk a little bit about security. I love the topic and cloud native applications and container applications. I'm very new at that, so it will be fun.
We can start at the beginning and
yes,
work through.
Exactly. I've been starting from the beginning. I already did a couple of videos on the basics of containers, so I think now I'm ready to tackle the security aspects of these things.
Excellent.
Yeah. Tell me a little bit about yourself, what you're working, how's life?
Yeah, so I am here in my home office in Enfield, North London. I work. My day job is I look after the open source engineering team at Aqua. So we're building open source tools to complement the products that Aqua sells to secure cloud native deployments. And actually quite a lot of our open source tools end up becoming part of the overall security platform that Aqua's building. So yeah, my day job is really working with that team on our open source tools. And then I'm also spending quite a bit of time with the Cloud Native Computing Foundation, the CNCF, where I am currently the chair of the Technical Oversight Committee.
Maybe you can share a little bit about what is the CNCF, because I've been thinking about making a video forever, and now I have the perfect guest to introduce it.
Yeah, so the CNCF, Cloud Native Computing Foundation, it's part of the Linux Foundation, so it's a non-profit, and it's the organization that it's home for Kubernetes and a whole load of other cloud native projects. And it exists really to hold the intellectual property for those projects. So it makes it easy for lots of different companies who might otherwise be competing. They can come together and collaborate on CNCF projects. And that's why, all the big cloud providers, lots of, vendors who would otherwise compete are able to work together on all these amazing projects.
So it's for a lot of open source projects there.
Absolutely, yes. Yes, everything that the CNCF owns is open source. But we do have a huge community of vendors who are members of the foundation who it's all part of an ecosystem, right? And people are end users are running their businesses. They're using cloud native to make it easy to deploy their applications and ship business functionality quickly. And there's a whole array of vendors who are selling products to help that. And then of course there's literally thousands of that, literally hundreds of thousands of the people who contribute code, documentation, or other things to support the open source projects. So it's a huge community, cool. The CNCF, absolutely huge.
That's super cool. So if somebody's contributing to Kubernetes, for example, they will be contributing to the Cloud Native Computing Foundation.
Exactly. Yeah.
Nice.
Yeah. And it's the CNCF that organizes things like KubeCon, Cloud Native Con.
Yeah. Nice. So it's quite an important part of our ecosystem.
Yeah.
So that's so nice that you mentioned that, because as I said, I wanted to introduce this foundation for a long time, and it's always hard to know where to put it, and now it's there. So we can move a little bit to the main topic of today's conversation, that is the security aspect of building cloud native applications. And the first question I have for you is, what it changed when you are building on the cloud, when we were building on premise, from a security aspect? What are the things that we need to be aware?
Yeah, so lots of things don't change, like the things we're trying to secure against, whether it's, everything from people sort of inadvertently, hitting the wrong button or something and accidentally creating a DDoS, to somebody who's actually maliciously trying to, steal your data. Or the most common attack that we see these days is people trying to take over your resources and use it to mine cryptocurrency. So there's a whole range of different types of thing that what we're trying to protect against.
Yeah. I think that taking your resources in cloud is even more dangerous than on premise, because on premise you have a very limited amount of resources. On cloud,
well, yeah, it's true. Yeah, maybe you want to have. It's one of the reasons to have alerts built into your clinic, right? Yeah. Although sometimes we do see these attacks being really quite sophisticated. They won't necessarily use unlimited amounts of CPU or resources, because you might spot them. You're more likely to stop them that way. So quite often they're quite subtle, and they'll just try and, maybe just increase your usage by 10% or 20%, and you might not notice. But that's one of the reasons why it's really helpful to be able to know what's running in your containers, what's supposed to run in your containers. And we can actually use that in building security tools to spot anomalies and spot these unexpected cryptocurrency miners, for example.
Exactly. And what is running in your whole account or in your whole organization, because it can be a container or it can be a virtual machine, but somebody put something there that it was not supposed to be.
Yeah. And at the end of the day, it's all about applications executable programs.
Exactly.
I quite like taking things down to what's really happening here, and in the end, it's a program running on CPU, and that program, I was going to say has a name, doesn't always have a name, but quite often, because you can run files from memory, or you can run execution from memory. But anyway, you're executing code, and you want to be able to tell the difference between the things that you expected to run, your intended application, and these imposter things that are coming in to mine cryptocurrency or steal your data or whatever.
Yeah, exactly. So what else we have there that we should be aware?
Yeah, so one of the main things that I end up talking about when we think about containers is really comes down to what containers are. Containers are really just processes in Linux. They're isolated. They have a limited view of what else is happening on the host, but they are fundamentally just processes. So I could show you what I mean.
Sure.
All right. So I've got a virtual machine here with a couple of windows into the same machine. And if I run a container, I'm just going to run Ubuntu. I get a shell into a container. And you can see here it's run with the user ID root, and I can check that I am root. And I wasn't root when I started this. I was a user called Vagrant when I started this. So I think sometimes people see this and they think, oh, okay, yeah, but I'm just root inside the container, and the container is, in some way they think of it as like a little virtual machine on its own. But this is actually root on the host.
Oh,
And
really?
I can prove this. So let me run I'll sleep for a long time inside the container. And then in the other window, I'm going to look for that process. I'm going to look for any sleep processes on the whole virtual machine. And there it is. That, there's only one. So it must be the one that's running inside my container. And you can see it's running as root.
Wow.
Yeah. And I think also it's actually conceptually quite important or helpful to recognize that, from the host perspective, it's just a program running sleep. I could also find, if I run a whole tree of processes, we can find this process in here somewhere. Yeah, so you can see there's my sleep process, and it's running inside a bash shell process, and it's been started by container D. But that it's just a process from the host perspective. Yeah. So anything that's running inside the container, it's got a limited view. I can't see all the other processes running on my host from inside the container. The container has this limited view. And if I look in the root directory here, this isn't the same root as my host. But because I'm root inside the container, if there was something that allowed me to escape, some kind of vulnerability in the container runtime, if I get out of this container, I'm root on the host.
Yeah.
And that's
very dangerous.
Potentially, yeah. I mean, I don't want to give the impression that container escapes happen all the time, but we're trying to defend against the unexpected. And so this is kind of I think a really important thing for people to recognize.
And what you need to secure here in order to prevent this is to keep your Docker machine, your instances, like to the latest versions possible, or what is a good practice to try to this?
I think updating machines and updating software is absolutely critical. But let's explore one other thing first before we get to that, because that kind of gets into dependency management. But I could run this container with a specific user. Oops, I think I could run it as, let's say, user 1000. And it didn't recognize that user inside the container. Actually, if I run ID. So I'm not user ID 0 anymore. I'm not root anymore. And this is one of the really sort of easy things you can do when you're running containers. Is just where you can run them as a non-root user. And that would make it much more difficult if this escapes. If there were to be a container escape, it'll be less dangerous if it does escape onto the host.
Yeah. Sometimes it's hard to give the exact privilege that things need to have, and so it's.
Yeah, it is. I mean, I've rather made that sound easy. Like all you have to do is specify a user.
Exactly.
And unfortunately, there are quite a lot of containers or container images rather, that expect to run as root.
Uh-huh.
Maybe. Say, for example, you've got a web server, and it was designed to run. I mean, Nginx is a good example. It was originally designed to run on a host machine where it was fine to run as root, and you expected that it was going to be serving on like port 80 by default. And if you want to open to port 80 or a low numbered port, you need some privileges to do that. And running as root gives you those privileges very easily. So that's the normal way of running Nginx. There are versions of Nginx. People have gone to the trouble of making versions that don't need to run as root, but the default image that you'd pull would run as root, and you'd have to do some work to make it possible to.
That's a typical thing. I think one of the first things that you will get when you are playing with containers.
Yeah,
the image of Nginx.
I do a lot of demos that involve using Nginx because it's so useful.
It's so easy.
And you can do the equivalent of this. You can build it into your container image by using inside your Docker file, using a user command and kind of make it run as a non-root user by default. So that's a good practice.
That's a good practice for then whoever used that image will not have a choice. We are getting the user that is not root.
Yeah, exactly. I mean, they could override it if they tried, but at least by, out of the box, they'd get a non-root user.
But that's a good practice to prevent.
Definitely.
People not knowing about these things, because I didn't know that the root of the container was the root of the host.
I know. I remember first seeing it myself and thinking, wait a minute. That's interesting. Yeah,
that's how it goes. And then if you have, for example, if you are in the cloud that machine might have access to other parts of your, I don't know, your files or whatever, then things starts leaking down. It's quite
well, right, exactly. And you can do things like mounting. Let's do another crazy thing. So let's say I mount a volume from. I can never remember which way around this goes. I'll do it like this. So I'm mounting the etc. on the host into my container. So if I look at what's in etc., that should be the same as I see on the host. And I can do things now like look at the password file. Right? And that is because I've mounted it from the host, it's that is the host's password file. The thing that I've done there that was really dangerous is that I mounted this directory. That's kind of a foolish thing to do, a not very secure thing to do. But checking for whether you're mounting sensitive directories like this from your host into a container, that's another good thing to do. It's one of the things that some of the security tools will check for.
Yeah, definitely, because sometimes you mount things that you don't have a clue what you're doing.
Well, right, yeah, and actually, say you might download YAML from the internet in the Kubernetes world, and you get 1,000 lines of YAML. Somewhere in there, there's some volume mounts. You kind of need automation to check things like that, because otherwise it's a lot of work.
Yeah, and more if you're like starting out, because I think these are the typical problems that, for example, I will never realize these things. If I'm doing a demo or trying code, this works, I will leave it, and then maybe I realize that this has this power. And maybe for that time it's too late. And there is so many people getting started with Kubernetes and containers and the cloud and all these things. So learning this type of things from the beginning is quite important. So then you have eyes open, like, okay, if I have a root user, that's very dangerous.
Yeah, exactly. Now, hopefully a lot of this will improve over time. I think a lot of people have realized, when people first were building containers and Docker were first becoming really popular, everybody's very excited about running containers and all the benefits that it brings. And then, over time, we've realized that, well, perhaps some of these default behaviors, like running as root by default, maybe, that's encouraging people to do things that are pretty insecure. And it would be better if the default behavior was more secure.
Yeah, and I
so
think
one thing
that happens everywhere with serverless. At the beginning, everybody was giving like the functions like root access. Basically, all the functions were getting star for everything. Like, yes, just whatever.
Yeah.
And now the policies are embedded in most of the frameworks, like how to define very granular policies, because your Lambda function is running on top of a container, and if you give star access to all your S3 buckets, somebody can take it over.
Yeah.
It's not possible, but it's not probable, but it's possible.
Yeah. And there's a security principle called least privilege, which is the
Exactly.
idea that like you just only give out the permissions that something really needs.
Exactly.
Because if you give extra permissions, there's a possibility that could be abused. And if you don't give out the permissions, well, that's made things safer and less likely to be abused.
But sometimes tutorials don't come with the permission of least privilege because they don't want to get in the hassle of explaining security as one of the first things. And I think that's what I was quite excited to bring you over after. Well, we learned the basics. Now let's look at the security aspect, and then maybe we can continue digging a little bit more in this container world, because I think it's very important when you're starting to learn something, at least that you understand the basic security principles that you need to have in place.
For sure. And I think one way that this will improve, this is, it's going to take a little while, but there's a thing called rootless containers, which basically doesn't behave the same way. So if you're using rootless containers, first of all, it doesn't automatically run as root. You can run as a non-root user by default. And secondly, so for me to run Docker at the moment, I have to be a member of this, where is it gone? Docker group here. And what that allows me to do is not just to run the Docker command, but when I run Docker commands, that's sending a command through what's called the Docker socket, and it's speaking to the Docker daemon. And if you're allowed to run containers, you can. It's effectively like root access, right? Because like, as we've seen, I could just run a container, and it ran as root, and I could mount any directory. I could mount a whole file system if I wanted to. So that means anybody who is a member of this Docker group, they effectively have root privileges. And that's meant, like, if you're sharing a machine, you can't necessarily allow people who don't trust each other, to run Docker. And the idea, or one of the things that rootless containers allows you to do, is to start containers without having to have these kind of privileges. So you can be a non-privileged user, you can still run containers, they're not running as root. This is far better for whoever's administering that machine. And it means you don't have to run. You can look like root inside the container without being root from the host perspective.
Is that available already, or is it coming?
Yeah, so the underlying support in the kernel has been there for quite a long time, and it uses a thing called user namespaces, which allows you to map between having a user ID inside the container maps to a different ID on the host. That's been there for ages. The support has been experimental in Docker for quite a while. I want to say since an earlier, like a 2019 release, there's been a experimental rootless mode. And I was actually recording a talk about rootless just a few days ago, and I noticed that the latest version of the release notes for Docker say that rootless is graduating to, out of experimental.
Nice.
So I think we're going to see that, proliferating pretty soon.
That's cool, because that type of things are the ones that improve everybody's usage of the whole container ecosystem, because it comes built in.
Exactly. And there's a enhancement proposal for Kubernetes that people are actively working on. So hopefully, in a relatively short period of time, we'll start getting rootless access, and that will be a huge improvement.
Yeah, coming with the least privilege out of the box.
Yeah.
And what other security principles we should follow when we are working with containers in the cloud? Because least privilege is one of the most important for whatever you do in the cloud, not because
absolutely
unlimited resources. So You don't want
Yeah.
to share that.
I think a lot of the principles are really the same, whether you're, it's more the implementation of the principles. So, I mean, you mentioned earlier the idea of, updating software.
Yeah.
And this kind of speaks to, in the container world, the fact that, you wouldn't just be running one virtual machine or a handful of virtual machines. We're moved to this like DevOps world where you're running thousands of containers and they're all being scheduled. Maybe Kubernetes is running containers on your behalf across, a set of virtual machines, possibly machines that you don't even have access to. Maybe you're using something like EKS where Kubernetes is managed for you. And
or Fargate, where you even don't see your instance running inside your AWS account.
Exactly.
They're disappearing.
So you don't even know what machine it's running on. You have no access to that. And things can be changing really fast. The container, the average lifetime of a container in production is, I think, is around about a day at the moment.
What?
Yeah.
That's nice.
So, if you're a security person who's used to, I don't know, monthly security patches, you can't do that in a container world because everything's changing much more quickly.
Wow.
So we have to think about automating that kind of patching process, making sure that we're running up-to-date dependencies. We've got updated packages in all our container images. So one of the tools that has become really important for this is vulnerability scanning for container images. And I can show one. So we have one that we work on in my team called Trivy. It's an open source tool, and you can just scan any image. I know I've got Ubuntu because I was just running it, and it's just going to download the vulnerability database to make sure we're looking at the most up-to-date vulnerability.
And who maintains that database? It's an open source project, so the community or?
Yeah, so the data comes from a variety of different sources. So there's, tell you what, let me just make that a little bit smaller so it fits on the screen. And you can see there's a few issues. I doubt there's anything terribly serious, mostly low severity issues. And they have these CVE identifiers. And the database, or the primary database of what all these different vulnerabilities are, is held by an organization called the NVD, the National Vulnerability Database.
Okay.
And so that's the kind of starting point for vulnerability information. But that would say, it might say, this particular vulnerability affects Bash version 5.0.
Yeah.
But you can see here the actual version that's installed, it's got Ubuntu in it. The maintainers of Ubuntu have they've not taken just vanilla Bash. They've done some kind of patching update. So we need to get data not just from the NVD about this vulnerability. We also need to get information from, in this example, Ubuntu, to know whether or not they've patched, whether this particular version is patched. And it presumably isn't, because the vulnerability is here.
Yeah.
So, and this kind of patching process, every Linux distribution has its own kind of patching process. Like Debian and Ubuntu have a philosophy where they basically only, they don't want to be shipping updates to packages, or they don't want to take new releases of packages frequently. So they apply like security patches to the source code and rebuild their own patched versions. Other Linux distributions might be more inclined to say, you know what, we'll take Bash version 5.2. I'm making up the number, rather than patching it ourselves. even if that means that maybe there are some other changes that aren't security related. So different distributions take different approaches. They have their own feeds of the vulnerability information. So a tool like Trivy has to pull all of these different sources of data together and then make it available. So we're pulling security feed information for several different Linux distributions and also for some language packages as well. So things like Node will have a feed of security issues, and Ruby does, and Python does, and so on and so forth.
And what you can do with this information now, for example, there were a couple of medium, vulnerabilities. Can you do something with it?
So there's a couple of things you might do with this. One is you would typically have some kind of policy that says, I don't want to run any container images in my production deployment if they have vulnerabilities over a certain severity. So very typically you'd see if it's got any high or critical issues, I don't want to run it. So just scanning those images and preventing things from being deployed if they have significant issues.
So this is something you will add, for example, to your CI/CD pipeline. In the moment that you create the image, then you will add this validation.
Exactly. And then if you put it in your CI/CD pipeline, the developer who's using those dependencies, as they build their image, they can see, actually I need to update this package because I can see it has a vulnerability that I need to worry about. So you can do that step at the kind of development phase.
Yeah.
But the other thing that happens with vulnerabilities is new ones keep getting detected in existing code. So, whatever you built yesterday, some researcher might have found a new vulnerability today. So, your scan might not be up to date anymore. So people are typically scanning their container images on a daily basis. Is pretty common to check whether there are any images that need to be rebuilt to pick up new fixed versions. So if I look down here, I'm wondering, there probably aren't any fixed versions for Ubuntu. Let's scan an older image. I think this might be so old that
it's all red.
It's a pretty old image, and it's certainly, it's basically said it's too old. Let's think of another. I think there's an old version of Nginx that has a lot of issues in it.
Yeah, but I think automatization it's very important in all these things.
Hopefully we'll get. Yeah, I'm getting
remember
some
old images.
Yeah, pretty old images. I need to remember what versions are old enough to have some interesting vulnerabilities. These keep changing all the time. Here we go. This is better. Now let's see if it's got any fixed versions. I'm just making it a bit smaller so we can see.
There is some
here's an example where there's a high severity or a couple of high severity issues in this installed version, and there is a patched version available. So in this example, I mean, you probably wouldn't be building Nginx yourself, but suppose you had your own application that showed a result like this, you'd know, okay, I need to update my, maybe it's in your Docker file, or maybe it's in the packages you're installing in your build process to make sure you're picking up this patched version. And then you'd rebuild your image. If you had any containers running based on the old one, you'd want to replace them with the new one.
Yeah, and about replacing containers, do you like to talk about this concept of immutable infrastructure that I think is quite interesting? And I think in this word that you say, like the lifespan of a container is one day. How
Right, yeah. Yeah.
maybe we can chat a little bit about that, because I love that topic, at least for the serverless world.
Yes, so immutable infrastructure, immutable container images, cattle not pets.
Because I think we were used to thinking about machines like we keep on patching them and making them better, and we give them names, as you say, pets.
Exactly, yes, yeah. And you got to stop doing that. You got to remain emotionally detached from your machines. And yeah.
Yeah. So what
So,
is
so
immutable infrastructure, if you want to
yeah,
share?
exactly. So the idea is to be able to use infrastructure as code, use configuration, use scripts, so that you can just rebuild your machines, rebuild your container images, recreate whatever you wanted running on those in that deployment, in an automated fashion. Do it all with scripts. And there's so many benefits to this. One of the things that I think is great is if you have a cluster of machines and you know that you can just kill one off and you have all the scripts in place that will automatically recreate whatever you need, then if you have a failure, if your machine,
Exactly.
just dies in your data center or, public cloud VM instance.
Everything fails all the time, so the chances that it
Exactly.
dies, it's quite high.
Yeah. So having, that good practice around, everything will just recreate itself automatically means you're much more resilient to failure. It's not just about having, um, not having to manually patch things. It's
Exactly.
also about just recreating things in the event of
And you can
failure.
have the image tested, make sure everything is good, and then you just deploy it to, I don't know, you need to patch the operating system instead of going to each machine and adding those patches. You just have this image that it works with the latest version.
Yeah.
Just
And
deploy it.
another thing that's pretty cool from a security point of view is, like, suppose, you do have, this could be at the host level or the container level. If somebody has compromised your system and they are, in your
Inside.
system somewhere, and they've maybe installed that cryptocurrency miner or whatever it is that they want to run inside your deployment, if you destroy that, from time to time, you destroy the whole node. Anything that's unexpected gets killed, and you
Exactly.
recreate it in the state that you intended it to be in the first place. So
That's a really
hopefully
powerful
you've been
thing.
able to catch any issues beforehand, stop that malicious behavior. But it does give you a way to, know you're getting back to a known state, a known good state.
Yeah, and also for the attackers, if they know that that's a practice, it's not that interesting to try to attack maybe your host and install things, because they know maybe every week you kill everything and you start from fresh, and it's not that
Yeah,
tempting
although
anymore.
I mean, I think some attackers would see that as a challenge. So,
True, depending what they are doing for what they are doing.
Yeah, exactly.
Yeah.
But yeah, you can certainly make life harder for them by
Exactly.
destroying things and
That's the
recreating
life
it.
of fighting attackers. Always trying to make the life a little bit harder.
Yeah.
Yeah, but immutable infrastructure, I like it. For me, the best things is the known downtime, because you have already the things prepared and you just like click.
Right. Yeah.
And if
Bring up
something
a
goes
new.
wrong, you just throw it to trash
Yeah.
and start over. And I think that's something at least people are not really kind of, they're starting to talk now, but it's not something that is that uh, broadly seen. Like, people still go and patch their machines even in the cloud, and
Yeah. I mean, the future is much more about. I mean, another thing that's good about sort of immutability is the scale. If you need 10 more machines, great. Like, let's build 10 more machines. They can all be exactly the same, and you can use orchestration to, to scale up your deployments, and you can do that on demand. You can respond to, your website suddenly becoming popular.
Oh yeah,
it's
exactly.
great to be able to do that automatically.
Yeah, and I think automatization is one of, at least for me, one of the most important things in general when you work in the cloud, and that helps you from not only from scale but also for security aspects, because the more automatization you have in place, the less places that you have for making mistakes. That
Totally. Yeah,
sure, you
totally.
can make mistakes when you're configuring the automatization, but you can have processes to
Yeah.
review that automatization over and over again, but that leads to way less errors.
Yeah, and a huge amount of successful attacks are really taking advantage that somebody has made a mistake. They've left something, they've left a port open, or they've left some permissions open that they didn't really mean to. And so, human error is a real thing. So trying to automate as much as possible and have people doing things manually as little as possible helps us, avoid those.
So
Mistake.
in the terms of automatization, what are kind of a good best practices to have when you're building like container images in the cloud and deploying your like applications on them? Maybe using this immutable infrastructure, but some good practices that people can start taking like right away.
Yeah, so I mean, there's a whole range of things that can be built into your CI/CD pipeline. We've talked about vulnerability testing. Obviously people do functional testing and perhaps even non-functional testing as part of their pipeline, which is, all good and helpful. Making sure, so you need to know that the images that you're going to deploy are actually the images you intended. So the whole thing of like supply chain attacks.
Okay, what is a supply chain attack?
So the supply chain is the idea. It's a little bit like it's a metaphor. The sort of real life example would be, that if you buy, I don't know, a frozen pizza, you kind of trust that the supermarket knew where the ingredients came from and that nobody, nothing poisonous has gotten into that.
You're not having
you take
dog
that.
in your salami. It's just
Exactly. I didn't want to think of an example, but
I'm a little raw. I don't have any problem on putting example.
But you want to know when you take that packaged thing that it's not got anything unexpected and poisonous in it, right? And the same thing is true for container images. You want to know that the image you're going to run is safe. And that if you built that image, it really is the image you built and it's not being interfered with somewhere. So one thing that most enterprises do is run their own registries, so they can store their own images and test them and know that they've not been, nobody should have access to that. And in AWS, by default, you're using your own ECR, so you shouldn't, there shouldn't be a way for people to compromise those. You need to know that if you've pulled some base images from, let's say, Docker Hub, you probably want to check those out because, no disrespect to Docker Hub, but it's accessible to the internet, so there's more likelihood. And one interesting attack that our research team at Aqua found was a lot of images on Docker Hub, not the official images, but other images that have got cryptocurrency miners. And maybe they've got like a name that's very similar to an official image, but just with a little typo, And then if you've misspelt something in your YAML file and you're pulling, one of these images, that's your supply chain compromised.
Exactly. And I imagine at least one thing I think is a easy attack is to create images that are very practical, like, okay, this is a bundle with, I don't know, MySQL, Node, a web application that you can just put your app here and running, and you get it, and then it's like, this is perfect, and you don't have a clue what else is in there besides those things. It's not a NGX official image. If somebody built it, it sounds super cool. It's like that free Wi-Fi that you find in the airport. That you just need the Wi-Fi and you click on it and you just give access to all your internet connection. This
Click
is
here to give away all your worldly possessions. Yeah.
Because I have seen so many. I don't know if they are bad inside, but so many of these images that come like with this perfect combo to just deploy your Node application and have a little server with everything you need. In, like it's so convenient, it's so perfect, and I don't know why.
Yeah, and probably lots of them are really well intended.
Exactly.
There will be some that are, and you can't tell
Exactly.
the difference between the good ones and the bad ones
Exactly.
unless you test them.
And
So
there,
actually, there's an interesting thing that is part of the Aqua product. We call it dynamic threat analysis, and I mean, this is not an open source thing, but it is pretty cool nonetheless. Where we take a container image, run it in a sandbox environment, so basically not in your, we run it on people's behalf, and look at the behavior of the image and match it against kind of known malware, known bad behavior. And some of those, I mean, this is the reason why it's a paid for product, is because some of that, threat intelligence is pretty sophisticated, but some of it is pretty obvious, like a cryptocurrency might, if you run a container and, you thought it was running, let's say Nginx, that's always a good example, but actually what it runs is some completely different executable name, and it tries to open a connection to some IP address, and then you look up that IP address and it's a mining pool. Like, okay, that's probably cryptocurrency miner. So flag that image as not, unless you were intending to mine cryptocurrency.
Sure. You're free to do whatever you want, but but be aware that you're doing it and not someone else is doing it.
Exactly. So that's a pretty, I mean, it's another thing that becomes possible because of containers and container images. If every business in the world is running its own bespoke application, you can't really look at, it's much harder to tell, well, what's the expected behavior. But because we've got these known container images, it's much easier to say, well, this container image is supposed to run Nginx and it's doing something different. So it's, it's that kind of decomposition into these smaller pieces makes it an easier problem to find out whether it's doing good or bad things.
Yeah, and I think that's very important when we talk about this, getting images from maybe not super trusted places or open places. And I think one question I have is like, who is in charge of all this automatization and security? And because I imagine developers have a role, but I still don't believe like developers are aware of so many things. It will be crazy. Is the ops teams, we're talking about DevSecOps. What is that?
So the whole DevSecOps, put all the words together and build one word. But I think mashing the words together does reflect in some way the cultural change. And if we think about businesses who are adopting containerization, adopting cloud native, and if they're just doing it because like they think the technology is cool, that's probably not a good reason. They need to have a reason to do it. And for most businesses, in my experience, they're doing it because they want to shorten the time between having an idea and being able to get that idea in front of customers. So, agile, DevOps, shipping code quickly. And then you don't want security being a break on that.
Exactly.
Security has to be part of that process. And, traditionally, the kind of old-fashioned, developers build some code and operations people kind of, figure out the deployment where it's going to run and and then the security people kind of go, what do you mean you want to open another port? I'm not opening a port. It's kind of terrible cliche, but in many traditional organizations, security, they're responsible. They're not saying no for just for fun. They're saying no because they want to make sure it's safe to do these things.
And the problem, at least what I have seen in my previous life, is that they usually don't have the whole visibility, because you just make ask, oh, I need to open a new port, and you write a report, and then they get that, and it's like, they're not integrated in the team, they are not in the discussions, they don't have the same goals than you, that is to ship fast to the customer, they want to secure.
Exactly.
It's just everything so separated.
Yeah, so by bringing everybody together and having shared goals around, well, we want to ship this idea really quickly, but we have to do it in a secure fashion. So what are security's requirements, which might be things like, well, I want to know that you've used a known base image that I've previously tested, and that you're scanning your containers for vulnerabilities, or your images rather, for vulnerabilities, and that you're running the configuration. If you're using Kubernetes, there's a lot of YAML config, and there's plenty of test files that can kind of audit, or test tools rather, that can audit those YAML files and tell you about you're mounting this sensitive directory, or you're running as root, or all these things that are bad practice. And getting security to say up front, well, I want you to be running these things, let's get those into the pipeline, so that at the point where we're actually ready to deploy, we've got some confidence that it's safe.
Yeah, and I think, at least for me, the term DevOps is, well, it's not a role, it's like the mentality that Ops knows how to code and scripts and makes it like more automated, and Devs knows a little bit about Ops, that they can understand what they're doing and where they are putting their software, because before we're just building applications and whatever. And I think when you, at least my thinking, when you add sec in the middle, is that now everybody is aware that security exists and understands a little bit, and how at least the basics ideas, like what I was telling you before, like this is like very introductory to security on containers. And I think it's good to learn security from day one when you're starting to do something, because it's so easy to go to tutorials and build things up, and then, and now I need to learn to secure this thing. Oh, but it's so easy to do the other way around. Like, and then you already have the bad practices in place. You have all the bad habits, and it's hard to take down.
I think over time, security has become kind of a more, it's something that developers are getting more and more interested in. And for myself as well, my background is development, and, I've kind of gotten more involved in security, and there's so many interesting things about security. And I've seen, random conversations on Twitter where people will say, I didn't realize, I've come from development, and I didn't realize there was all this really interesting, infosec community and challenges and interesting things going on. So, that I don't think every developer needs to be a security expert.
No.
It's great that they can,
but at least having the understanding on what are the basic threats and basic things that they need to have in place, like best practices.
And understanding why it's important, and maybe getting to know some security folks in their organization, so they can ask for advice and work collaboratively on it, which is
I think that's one of the nice things of the cloud, because resources are so cheap that now you can empower developers, you can empower ops, give them a playground to play and try things, and you don't feel so bad. Like, before, if you wanted a server, it was super expensive to give you a physical machine for you to play, and maybe one machine is not really enough, you need more. And now you give an AWS account to your developers, and you put some wall rates there, and then you let them explore and play, and then they become more interested in security, in ops, and all these other things that maybe before they didn't have the chance to play with. And the same for other different roles in the organization. So I think that's making it so accessible is very encouraging.
Yeah.
Because I was never interested in ops until I have to start working with serverless, and I got my first AWS account at work with no limits, and I was like, oh, now I can play with this thing. This is interesting. I like this. Before I was very, very scared. The more you learn, the more fun things you can build.
Definitely. Yeah, that's such a good attitude, like the whole the realm. There's like no limits, right? There's always more things that you can learn, and then more things you can do with that knowledge. Yeah.
Exactly. And I think on that note, we can wrap up the interview, because we cover in the last hour so many interesting topics, and we went through one place to another, and I hope the audience have learned a lot of things. I have learned a lot of things, and now I'm afraid of root being the the root of my thing. Next time I will use that.
Yeah.
I really didn't know that. So that was really interesting, Liz, to have you and chat with you and have this conversation.
Thank you very much for having me. It's been a pleasure.
Yes. Have a great day, and we'll see you around.
Great.
Bye-bye. This was the video for today. I hope you like it. If you did, give a big thumbs up. And I see you in the next episode of FooBar. Ciao, ciao!